So number one was just basically just definitions here. Okay. That was number one. One was just a definitions kind of question here. Okay, 2 here says which of the following complexes or complex ions has geometric cis or trans isomers. So we're looking at this one here. So we have the first one here is A here. A here is this is the complex here. So it's cobalt and then NH3 and then 2 and then Cl2 and then 2 minus. B here has a Cr group, NH3, bond 4, and then this is Cl2. This is plus. C here is another chromium group, NH3, 5, and then Cl2 plus. And D here is this is PT, NH3, 2 Cl2. Cl2, oh whoops. 2, this is a 3 here, 2 Cl2, and you make a square planar. So the first one here is a tetrahedral one. Again, if you have cobalt, it's bonded to 2 ammonium ions and 2 chlorines here with a charge of 2 minus. It says that here it's tetrahedral. So this one would not have an isomer here. This is a tetrahedral one. Will not have not have one here. This is a chromium as well. This here is this one would give you it's bonded to 6. It has 6 bonds, right? So chromium here makes 6 bonds here with 4 of them which are with ammonium and 2 of them with Cl2. Option B here is octahedral, right? Because if we were to draw this out in terms of VSEPR theory, so we're looking at VSEPR, and if you look here, we have Cr, and it's bonded to 4 different things. So it's bonded to 1, 2, 3, 4, and then 5, 6. So you have Cl, Cl, NH3, NH3, H3N, H3N here. So it's bonded to 6 different things here, right? This is a great example of octahedral group, right? So this here is octahedral for B here. C here is also an octahedral group. Again, it's just replacing one of these chlorines with a ammonium group, so it's also octahedral. So tetrahedral and octahedral shapes here. They have this one is an octahedral for B, and C here is an octahedral for C here is an octahedral as well, and D here I would get get something like a square planar, right? I have platinum in the middle, and then I would have basically this would be the NH3 group. This is the NH3 group as well. This is Cl group and Cl group here, and this one you could have a cis or trans isomer depending on the stereo isometry of the geometry of this one here, right? Depending on where it's bonded, maybe chlorine could stick out or NH3 can stick in, and it could have a cis or trans isomer. So the option D here, I can prove to you that this one here has a isomer because this here is a square planar and not a tetrahedral. If it was tetrahedral, then it would just be no matter how you rotate it, no matter how you rotate it, it's not a chiral center. So this one would not be it would not have a geometric isomer. So in terms of this one, A here is not correct, D here is correct, and we're looking at these two guys here. So we have option B and option C here, and both of these guys here have the number 1 here. So I have, again, 6 bonds here, and the chromium would have a positive charge here. And C here would have, option C here would have chromium having a 2+ charge. If it has a 2+ charge here in this case, this would not be octahedral. This would be I believe it's a it's not a seesaw. Just give me a second. I have to, let me bring up VSEPR theory, and let me just check that for you as well. There's a chart that says which kind of a geometry if it would be. So this one would have 6. So this one here would be a square pyramid. Sorry, this one here, this 2+ charge would give you a square pyramid. So square pyramids for C would have a square pyramid here type of shape, and this one would be octahedral in shape. So again, with octahedrals can also exist as cis and trans isomers, so it makes B the correct answer, and C here, square pyramids cannot give cis and trans isomers. So in this case, B and D are the correct answers here, and they said here that's correct, right? B and D are the correct answer. D and B here. Octahedral can exist. Also, the platinum complex as a square planar can also exist as a cis trans isomer here. Tetrahedral cannot. Also square pyramid. Ma5B here, square pyramid, cannot give cis trans isomers. So good. Solution and analysis. Good use of VSEPR theory. VSEPR theory to solve the question. And what they could have put, actually a chart here for VSEPR to say which geometry that they would have in 3D space, and then they would, in order for you to get that, then you could figure out if it is indeed, if it produced geometric or geometric isomers in space.